Hi everyone, in this video we're going to go through the measurement section of your exam revision theory. This is a long section, so I'm going to maybe skip a few things just so we can keep this video between 20 and 30 minutes. I don't want it to go over 30 minutes, but we'll see how we go. All right, so first key idea is converting units. So you do need to have this in your, well, you don't need to, but I strongly encourage you to have this in your bound reference. So it just means when we're going from units of measurement, so we can have millimeters, centimeters, meters, kilometers, what do you do? Okay, so just reading your table. So if we're going from kilometers to meters, we're going to multiply by 100. If we go in the other direction, so if you want to convert from meters to kilometers, we divide by 1000. Now, if you want to go multiple, and what I mean by that is if you want to go from kilometers to centimeters, you times by 100 to get it to meters, and then you times by 100 to get it into centimeters. Okay, so we leap. When you're looking at questions, do make sure that your sides are in the same units. So I think there was a question on your measurement test where one didn't have them in the same units. Okay, so you probably may have got that wrong if you didn't notice that. So just make sure they're always in the same units before you answer a question. So if one was in millimeters and the other one in centimeters, you got to make the conversion first. All right, so let's have a look at some building understanding questions. So convert the following length measurements to the units in the given brackets. All right, so the first one, we're going from centimeters to millimeters. Let me just erase all this pink stuff all over here. And I might use a lighter. Okay, so we're going from centimeters to millimeters. So we're going in that direction. So we're going to multiply it by 100. So we just go 10. 5 times 10 is 50. So 50 centimeters is equal to 50 millimeters. Sorry, 5 centimeters is equal to 50 millimeters. All right, B, this time we're going, just delete that, from meters to centimeters. So meters to centimeters, we go across by multiplying by 100. So put 2.8 times 100. All right, we're going to get 280 centimeters. Let's just do one more because it's going to take forever otherwise. Let's go from meters to kilometers. So if we're going from meters to kilometers, this time we're going in the other direction. So we're going to divide by 1000. So we're going to end up with 2.170 kilometers. Sorry, I had to think then. All right, a steel beam is 8.25 meters long and 22 meters wide. State the length and the width of the beam in centimeters. So let's just draw it first. So a steel beam. All right, so it's 8.25 meters long and 22.5 millimeters wide. So we'll do the 8.25 first. So 8.25 meters is equal to 8.25. So going from meters into centimeters. So meters into centimeters, we multiply by 100. And what do we get? 825 centimeters. And then 22.5 millimeters. All right, so this time we're going to do division. So divide, not by 100, by 10, sorry. And we get 2.25 centimeters. All right, part 3, give the values of the perennials in these shapes. All angles are at vertices are 90 degrees. That just means they're all right angles here. Okay, so sometimes you're given a shape and you have unknowns. So we've got a B here and an A here. So we've got to use the information we have to work out those values. Okay, Okay, so if I know this is 10, that is made up with this length here and this length here. So if I put them together, it's going to be 10. So what do I add to 7 to get to 10? So it's going to be 3. And then on the other side, I've got 3 centimeters here, 3 centimeters here, and that's the same as this one here, B. So B is equal to 3 and 3, which is 6. All right, let's have a look at question B. So this length, oh, actually, these 2 dots here mean that this length here is the same as this length here. So A is equal to 12, and that is also equal to this side here plus this side here, so 8 plus B. So what do I, let me just do that. So 8 plus B is equal to A, but we know A is 12, so that means B is equal to 4, and we don't have to do the 2 other sides. All right, with this one here, let's see where we can start. So these 2 are the same, okay, because you've got the 2 lines, so that means B is equal to 3.1, and that means A is going to be 2 times 3.1. Actually, I don't think the B, I don't think that's B. I think the B is just being, I think that's 3.1 there. I don't think B is 3.1. I'm just going to get rid of that because B is this other side. I might just highlight that in pink, this side here. So that B and this side is equal to this. Now A is still 2 times 3.1. So 3.1 plus 3.1, which is 6.2. And B is equal to 5.9 minus 3.9, which gives us 2. All right, and then the last one. Where am I? Okay. So A and this side here, which is 3, is equal to 12. So A must be 9. And then B, if we look on the other side, we've got B plus 3 equals 10, so B is equal to 7. All right, so I'm not going to focus too much on these shapes because you've done them for quite a while, but I might spend a bit of time on the stuff that you would have learned this year. Okay, so with the circumference of a circle, I know this isn't new, but I just want to make sure, oh gosh, come on. I think my computer is going to get cranky with me soon. So, oh, I wanted blue. Thank you. So remember the circumference formula, the one you use just depends on whether you've got the radius or the diameter. So your radius is from the middle outside and your diameter is from one end to the other. Now, a sector is just a part of a circle. So you need to know this formula for perimeter of a sector. All right, so your perimeter of a sector is made up of 2r. So we've got to include these 2 sides. So that's where the 2r has come from. And this part here is just a part of the circumference. So the proportion of it is just theta divided by 360. So we just got a fraction of it times 2 pi r. Okay, so whatever theta is, you just substitute that in. Okay, so that question wasn't done too well on your measurement test. All right, and try to use pi, not 3.14. Okay, I'm not going to do the building understanding for them because we did do quite a bit on measurement. All right, then you've got all your measurement formulas here. Okay, so quite a few. Just make sure that they're in your bound reference and you use them. Okay, what do we got here? Yeah, I'm not going to do that. Okay, let's scroll along. Just notice this one here. Question C. So with question C, your value of theta is this part around here. So this is a 90-degree angle, which makes this a 270-degree angle. All right, so when it says what fraction of a full circle, that's when you do the theta over 360. So this first one is 90 over 360, which simplifies to a quarter, which you can see. 120 over 360, whoops, which simplifies to 1/3, so it looks like a third. 270 over 360, which simplifies to 3/4, which you can see. 60 over 360 is 1/6. 225 over 360. Oh no, now I've got to bring out the big guns, bring out the calculator. 225 divided by 360. And my phone is giving me a decimal answer, so I'm just going to do it as a decimal. And then 100 over 360. I'm going to have 0.27. Oh, there it is. Cracked it. Go away. See if it's going to like keep going. Oh, I knew it was going to happen because it was glitching before. So what was it? 0.278. All right, so I've just rounded that one as well. Okay, probably good to quickly move through these. So we've just done this topic as well, so hopefully still quite fresh in your mind. All right, with composite shapes, so the term composite means it's composed of more than one thing. So composite shapes, you do need to separate the shapes. So if we look at the building understanding question 1, we've got a rectangle and a semicircle. With B, we've got a triangle and a semicircle. And I always get my shapes mixed up. So what is this? A parallelogram and a rhombus? It's also another parallelogram, just a different parallelogram. Okay, so just filling in the missing spots there. So just making sure that you know the shapes. All right, so first of all, doing the perimeter and then the area. When you're calculating a parallelogram, you've got your base. So the base is always perpendicular, to your height. So your height, I probably should have said, first is also always perpendicular to your base. All right, so I'm not going to do them because we need to move on. Total surface area. So when you're doing a total surface area, when we did it as a class, I showed you how to break it down into a net. So if you kind of thought if you had a tissue box, which is a rectangular prism, and you folded it all out, you're going to get a net. So you can either draw the net or you can draw the shapes involved. So it's a good idea to have these shapes. These shapes and these formulas, because you might have a rectangular prism or a square-based pyramid. You might have a triangular prism. Do I have triangular prisms? So triangular prisms, there's one here. So you got to work out the surface area of the triangles and then the surface area of the other side. So that's why breaking the shape up is important. I'm just looking at these. So we don't have to sketch any nets in your exam, but being able to break a shape up, a 3D shape into its net, is helpful for calculating total surface area because it just lets you see all the different shapes. So if we look at 2B, you can see you've got a triangle here and a triangle here. So when you're calculating it, you can say, well, I've got this triangle and I've got 2 of them. So I'm going to multiply that by 2. Then I've got, and then this is where it gets messy because I'm going to do a lot of colouring in. It's not going to let me colour it in. I wonder if we can use that. All right, so there's your base. Now that base is different to the other 2 sides because I can see that we've got 5, 3, and 4. So that's your base, and that base is going to be a 4 times 7. And what other colour can I use? Now we've got, 3 appearing. There's your back. All right, so there's the back of the shape. and that's a 3 times 7. And then we've got the front. So let's just pretend the front is clear, like a windscreen or something. Whoops, that's a weird pen. Okay, so your front is 5 by 7. So see how those 3 rectangles are all different, but our triangle, we've got 2 of them. So that's 4 and a 3, and we've got 2 of them. So you calculate the area of those shapes. All right, so the Building Your Understanding has broken it down for you. All right, then we've got cylinders. So total surface of a cylinder. So we've got the top and the bottom of a cylinder and also the outside. Just make sure that when you're using this formula, you're using the radius, not the diameter. Okay, so the formula is given to you with the radius. So if you have been given a diameter, you just need to divide it by 2. All right, now if you had trouble with them, just let me know. Now with prisms, if you've got a uniform cross section or a constant cross section, you just need to find out the area, and now I'm really glitching, find the area of that cross section and multiply it by the height. Okay, so there was one question in your measurement test that gave you the area, I think it was a trapezium, so you just had to, it was 16, I think, centimeters squared or something, and then you just had to multiply it by the length, which was 4. All right, so if you're given the cross section, the area of the cross section, you just need to multiply it by its height, its length, whatever. It's the same deal with a rectangular prism and a triangular prism. So this triangle is the same all the way through. So think of it as like a Toblerone. All right, so every bit of Toblerone is the same. And the rectangular prism, your volume, you do the constant cross section and multiply it by the length. All right, so but make sure you've got those formulas in as well. Now, I'm not going to spend time going through these, unfortunately, because the it's glitching. Maybe I'll pause. All right, so I just had to restart Word. So with your cylinder, I can't remember whether we got to cylinders or not. All right, so with the cylinder, it's the same deal. So we just do the constant cross section. So for this one, it's the circle. So we need to cut it where we get the same shape all the time. So if we cut it down the middle, we get a circle each time, kind of like a cabana or a salami or something like that. So your formula, what we have, this part here is the area of a circle, so pi r squared, and then you just multiply it by its height. Now don't worry about part 2, okay, because we didn't do that sort of conversion, so just work out the volume of the cylinders. All right, guys.